Welcome to myprojectbazaar.com. Now we can going to discuss about the product, a novel dual switching frequency modulation for jet source and quasi jet source inverters. Now we can going to discuss about the abstract of product. The impedance network inverters are best iterative for voltage source and current source inverters. The boosting capabilities and shoot through the solution of such converters makes the excellent solutions for various applications. In another hand, the hard switching forces the converters to operate the low switching frequency, which results in bulky impedance network. Moreover, the coupling between shoot through the duty cycle and the inverter modulation index makes the trade-off between voltage gain and modulation index. As that paper presents a novel dual switching frequency modulation to migrate the switching losses of the converter, which results more compact for impedance network. The proposed method combines a high frequency pulse width modulation with low frequency sinusoidal pulse width modulation. Therefore, switching losses decreases considerably. In respect to conventional simple boost modulation, in another two, the impedance network design the frequency maintains high and network size decreases the as process is obviously the proposed converter is approaches the interpretation of between shoot through the duty cycle and inverter modulation index. The comparison between proposed method and conventional simple boost method is performed to advantages over the conventional method, so that from analysis process to the proposed method. Next, we can going to discuss about the block diagram of our product. First, we can see about the DC voltage source. The DC voltage is a constant input source of the DC. It's an input voltage to pass the 100 volt of DC source. We pass it through the DC to AC converter. The DC to AC converter sections some conventional energy to pass the DC current to the change the AC current. Is stored as grid or used as load. These are two different processes as that process. The intermediate section of the combined high frequency pulse width modulation with the low frequency sinusoidal pulse width modulation. This is combined the switching pulses of the DC to AC converter of the powertronic switches to input applied our DC to AC converter. This is mainly operated at high frequency sinusoidal pulse width modulation with low frequency sinusoidal pulse width modulation. This is combined switching process to apply that DC to AC converter is a system as efficient and stable reliable of the DC to AC converter. To purely sinusoidal wave converter as DC to AC converter is a noise fluctuation also reduction in this process, so that load will perfectly absorb our system. Next, we can see the combined high frequency pulse width modulation with low frequency sinusoidal modulation, as that you can see these results. This is on carry, switch 1, switch 2, switch 3, switch 4. This is on sinusoidal waves reinsert. This is on high frequency pulse width modulation with low frequency sinusoidal pulse width modulation is an as per that. So our process is completely stable. Next, we can going to discuss about the running process of our product. First, we can see about the block diagram of our product. The proposed system implemented is done in a MATLAB version 2013A. The connecting circuit as per the circuit diagram of our base paper. The corresponding scopes are connected as per that. Now, this is our topology diagram of our circuit diagram. Corresponding scopes are connected. Next, we can see about the results. First, we can see about the switching pulses. We can see the switching pulses of our IGBT converters. See the switching frequency with the carry. This is a triangular carry with the switching pulses of 4.5 ways to pass the sinusoidal wave. You can see the switch 1, switch 2, switch 3 and switch 4. These are different categories to switch on and switch off the triggering pulses of our converters. Let's see, and it's a zoom level image. Now see right. It's a full view image. Now we to zoom the x-axis. Zoom in on. This is an as per that. PUC and sinusoidal wave. You can see the axis properties. The change over our axis levels as that. Similar that of another waves. Next we can see about the source voltage. This is an input of a source voltage, is a constant DC source of our power to send the 100 volt to power the input of source. Next we can see about the switching voltage. This is switching voltage, the difference between the one leg and to another leg, to of difference between of two legs to interact our switching, difference of the two legs converter levels. See, there is a constant DC. See that? Yes. Next we can see about the inductor current and capacitor voltage. This is our input passed through the inductor and the capacitor levels to pass over these two levels. This is our scope results of inductor current and capacitor voltage. Next we can see about the grid stored voltage, grid stored current. These two categories are the sinusoidal wave of input of DC, output of purely sinusoidal wave. As that is pure sinusoidal wave as becomes stored the grid. Next we can see about the this is switching pulses of topology diagram of the simple boost control with switch shoot through the solutions.